Chapter 5, Section 7, our topic is complex fractions. We are still addressing standard number 7. And a fraction is a complex fraction if its numerator or denominator or both contain one or more fractions or negative exponents. So here are some examples of complex fractions. 2x minus 4x over 3y is my numerator, and that contains a fraction. My denominator, 5x squared plus 2x over 6y squared, that contains a fraction. This is a complex fraction because of the negative exponents. A to the negative 1 is the same as 1 over a, plus b to the negative 1 is the same as 1 over b, and this is a to the negative third, which is 1 over a cubed, plus b to the negative 3, which is 1 over b cubed. Now, what I would like you to do is, instead of thinking of this as a hard or complex problem, yes, sorry about the pun, because they're complex fractions, I'd like you to think of this as 3 easier problems rolled into one. Your first job is to simplify the numerator. Second job, simplify the denominator. And then third, divide. And if we think of it like that, then it'll just be what we have already done, adding and subtracting fractions and dividing fractions, only rational algebraic expressions in this case. So let's start by taking a look at this, and we're going to color code it. So we can first of all simplify the numerator, that's in blue. Secondly, simplify the denominator, that's in red. And then third, divide the end result. So to add 1 to 1 over x, I need a common denominator, and the common denominator is x. 1 can be written as x over x. We're going to add to that 1 over x. We have a common denominator, so we're going to keep it and add or subtract the numerators x plus 1. And that's as far as the numerator can be simplified. So that's our first easy problem. Let's come back and add or subtract the red here and make that our second easy problem as we simplify the denominator. To get a common denominator in my complex fractions denominator, between x and 1, the LCD is x. We can write 1 as x over x and then subtract 1 over x from it. We have a common denominator. We're going to keep it and add or subtract my numerators to get x minus 1. That's as far as I can simplify my numerator, as far as I can simplify my denominator. So now let's think of it as dividing the blue fraction by the red fraction. And instead of dividing, the division rule says multiply by the reciprocal. So x plus 1 over x times x over x plus 1. When multiplying, remember that what we did is thought of it as one big fraction that somebody started to factor and didn't finish. And then we're going to finish factoring it, reduce any factors that are the same in the numerator and denominator. So x divided by x is 1. And we're left with x plus 1 over x minus 1. And that wasn't so bad. Complex fraction, just think of it as 3 easy problems all rolled into one. So let's take a look at our next one that we have with negative exponents. First thing is, let's rewrite it without those exponents so we can see the fractions. Remember that this negative 1 exponent only refers to the x, not the negative 3. So it's 3 over x. It's going to be 1 over x to the first. In the denominator we have 1. Then minus, that's going to be 2 over x. And then minus 3 over x squared. Let's think of it as 3 simple problems in one. To simplify the numerator, x can be written as x over x for 1. So x over x is 1. We have a common denominator of x, which we're going to keep, and we add or subtract our numerators to get x minus 3. That's as far as we can simplify our complex fractions numerator. Let's pursue the denominator. X squared, x, or 1 are my choices of denominators, so my common denominator is x squared. Multiply 1 by x squared over x squared, and 1 can be written as x squared over x squared. Multiply the second fraction, numerator and denominator, by x, so that's 2x over x squared, and the third fraction has the denominator that we wish. Now we're adding or subtracting. We have a common denominator, keep it. We add or subtract the numerators, x squared minus 2x minus 3. We've simplified the complex fraction denominator as far as possible. So we're going to take the numerator divided by the denominator, the blue divided by the red. Only we cannot divide by a fraction, so the division rule for fractions say multiply by the reciprocal. And we're not going to multiply. I suggested we think of it as one big happy fraction that somebody started to factor. We need to finish factoring, so x squared is x times x. And x squared minus 2x minus 3, using FOIL backwards, is going to give us x minus 3 times x plus 1. Any factors that are the same in the numerator and denominator divide out to 1. So x minus 3 and x minus 3 divide out. X and x divide out. And we're left with x over x plus 1 is our simplified answer. So if we think of complex fractions as 3 easy problems in one, it's not so challenging.